So today we're going to be looking at something called entropy, which is a big fancy word for disorder. We're going to represent this or abbreviate it with the big letter S. And we'll be describing reactions that either increase disorder or decrease disorder. Here's what we mean. Anytime we have a reaction that results in a bigger mess, we call this increasing disorder. And so we're going to abbreviate this delta S, meaning change in disorder, what we call entropy. So every time we have a situation that results in a reaction going from a more ordered condition to a messier condition, we would say this has increasing disorder, or we would say that the delta S is positive because we've gone from a state of low disorder, right, nice and neat, to a state of high disorder, which is this big pile. So in terms of chemical reactions, what would this look like in terms of disorder? So disorder in a chemical reaction is any situation where we have molecules that are in a nice organized group, and a disorder would be a situation where those molecules are a bigger mess. This could be a situation where we go from a solid to a liquid. Obviously, that would increase disorder because you can't spill a solid, but you can spill a liquid. Or we could have a situation where a liquid evaporates and turns into a gas. That would increase disorder, especially because a gas can evaporate and you never get it back. Both of these situations would have positive delta S, positive change in entropy, because they are adding disorder, they are increasing disorder. If we had a situation where a reaction went from a more disordered condition to a more ordered condition, we would call that a decrease in entropy. Let's see if we can find an example of that. So here's a situation we are going from a big mess, a bunch of scattered molecules, to a increasing, into a more ordered arrangement. And so because we're going from high disorder to low disorder, these would be an example of a delta S that is decreasing, because we are decreasing our entropy, we are decreasing disorder. So what would be some good examples of a reaction that is increasing disorder? Here's a good one. Here's our old buddy water, but it's in its frozen state. Obviously what we call ice. If we let it melt and become a liquid, and it runs all over the place, we would say that this has a positive delta S. If we take the reaction and run it backwards, we take liquid water and we freeze it to make a solid, we would call this decreasing disorder. It's becoming a more ordered system. So there's other things that we could look at in terms of disorder. Temperature is a good example, because high temperatures will always result in a positive delta S. We could count molecules, because a reaction that produces more molecules would always result in a positive delta S. Here's a good example. This is a reaction where ammonia decomposes into hydrogen and nitrogen. On this side of the reaction, there are 2 molecules. But on this side of the reaction, there are 4 molecules. This would result in a positive delta S because we are increasing disorder. It's kind of like if you have, maybe you're watching your next door neighbor's puppies. And so you're keeping these 2 little guys and you're trying to keep them out of trouble. Well, what's going to be more difficult to keep out of trouble? 2 puppies or 4? You're trying to keep them out of the flower bed. You're trying to keep them from running through the fence. You'd have a much harder time keeping track of 4 than you would 2. So we'd call a situation like this increasing disorder. So this is what we're talking about. Anytime we make a bigger mess, we have increasing disorder. And every time we take that mess and tidy it up a little bit further, we have decreasing disorder. All right, and that's really all we're looking at. So take it for a spin and let me know if you have any questions.